Hi students, so I've had some questions about Lewis structures for covalent compounds and ionic compounds, and I can see there's a bit of confusion on how to do these. So I'm making this video for covalent compounds and Lewis structures, and I'm going to give another one for ionic compounds as well. So remember, covalent compounds only contain nonmetals. That means that if you see a formula with two nonmetals, it's going to have covalent bonding, and the Lewis structures will be constructed following these steps. So remember, nonmetals want to gain electrons to have filled outer shells. The hydrogen wants to gain 2 electrons to fill its small outer shell because it's a small atom. All the other nonmetals want 8 electrons to have a filled outer shell. So remember, with hydrogen you're trying to give it 2 electrons, and with the others you're trying to give them 8 electrons. So in covalent bonds, nonmetals share electrons to obtain their filled outer shells. They share electrons in single, double, or triple covalent bonds. That is, when each of the atoms either donates a single electron, 2 electrons, or 3 electrons to make the covalent bonds. It's important to know that when you're drawing covalent molecules as Lewis structures, you do not do brackets because there are no ions and therefore no charges. These are the steps. So write these steps down, and then you're going to practice some covalent compounds. So the first one is to write down the chemical formula. So you might be given a name of a covalent compound, and then you write the chemical formula. The second one is to draw the correct number of atoms with the correct number of valence electrons around the atoms. So if you have a group 6 element like oxygen, you'll have 6 valence electrons. If you have a group 7 element like fluorine, then you will have 7 valence electrons. If you have a group 4 element like carbon, then you will have 4 valence electrons. Then, using single, double, and triple bonds, you provide each atom with a filled outer shell. We're going to do some demonstrations of this now. So the first one we're going to do is chlorine. So that's chlorine gas. Its formula is Cl2. We can also draw that like this. So we have chlorine, and it has its 7 valence electrons because it's a group 7 element. And we have 2 of these. Okay, so there are 2 chlorine molecules, or atoms. You can see that in the chlorine molecule, they're both missing 1 electron. So if they make a single covalent bond, they will both have their filled outer shell. So the resulting Lewis structure will look like this. Or you could draw it with the bonding electrons shown, like this. Either one of these is fine. Note that there are no brackets because there are no ions, so there are no charges. Neither one of the atoms here, neither one of the chlorines owns these electrons. They're shared between them so that each one has a filled outer shell. The next example we're going to do is ammonia, or NH3. We write the covalent formula, NH3, and then we draw the atoms out with their valence electrons. Nitrogen is in group 5, so it has 5 valence electrons. Hydrogen is the smallest atom. It's on the left side of the periodic table, and it's sort of in group 1. It has 1 valence electron. I say it's sort of in group 1 because it's not a group 1 metal. It is a non-metal, but it's in the group 1 on the periodic table. So these are our atoms in the molecule, and we're going to draw its Lewis structure. Notice that the nitrogen, which has 5 valence electrons, needs 3 extra valence electrons to form a filled outer shell of 8 electrons, and the hydrogens want 1 more each. Therefore, if we have single bonds from each hydrogen to the nitrogen, we will have filled outer shells for every atom. So that's what we're going to do. So I've finished drawing it now. This is the complete diagram. It's important to know that when you're drawing these, you have to draw the non-bonding electrons in. You could draw this like this as well. But you can't draw it without these non-bonding electrons. Because if we count this up, 1, 2, each of these lines represents 2 electrons, 3, 4, 5, 6, 7, 8. The nitrogen has its filled outer shell, and so do each of the hydrogen. Okay, now we're going to do a trickier one, which contains double bonds. This is for carbon dioxide. So we draw the chemical formula for carbon dioxide, which of course is CO2. And then we draw the atoms out with their valence electrons. Carbon's in group 4, so it has 4 valence electrons. Oxygen is in group 6, so it has 6 valence electrons. So the carbon has 4 valence electrons, and it wants 4 more to make a filled outer shell. The oxygen has 6 valence electrons, and it wants 2 more to make a filled outer shell. So when you have an atom that wants 2 more electrons, it's a pretty good indicator that it's going to have double bonds in the molecular structure, so in the Lewis structure. And that's what happens here. So we're going to have a double bond between each of the oxygens and the carbon, like this. So now the carbon has donated 2 of its electrons to each of the double bonds, and so have the oxygens. So there's 4 electrons represented by these double lines. So 1, 2, 3, 4, 5, 6, 7, 8. The oxygen has 8 electrons. Same on this side, and so does the carbon, because the carbon has all the electrons in each of these double bonds, which is 8 electrons in total. 4 here and 4 here. We can also draw this structure like this. Okay, let's do another example of a double bond. That is Br2, C, CBr2. So this has been written like this on your worksheets. It could also be written like this. So that's dicarbon tetrabromide. The reason that they've drawn it like the above one is it gives you an idea of the structure of the covalent compound. So what it's saying is that there's going to be two bromines attached to each carbon atom here. So the way they've written the formula indicates the structure. This won't always be the case, but if it is, it's a good indicator of the structure already. So we know that in this structure, you're going to have two of these bromines attached to a single carbon. So you're going to have two carbons with two bromines attached to each of those. Let's draw out the atoms here. Okay, so now we have our bromines with their 7 electrons around them. They have 7 valence electrons because they're group 7 elements. We now draw our 2 carbons with 4 valence electrons because they're group 4 elements. And now you have to decide how they're going together. We know that the bromines will want 1 valence electron to share with the carbon to make a filled outer shell of 8. So they're only ever going to make single covalent bonds. So we'll draw those in first. Here's our carbon. It's going to have single covalent bonds to each of the bromines. And then you draw their lone electrons in. We're going to have that on the other side as well, because there's 2 carbons and each of the carbons has 2 bromines. So now let's count the number of electrons in the carbons. 1, 2, 3, 4. Now remember, 2 of those 4 are from the carbon, so it still has 2 extra electrons left. This one does as well. We know that the bromines have their filled outer shell because they've got 2 electrons in this single bond, and then they've got their 6 non-bonding electrons as well for each bromine. So in order for the carbon to have a filled outer shell, it needs to have a double bond here. So basically, the 2 extra non-bonding electrons for each of the carbon molecules that we've drawn will come together to make a double bond, and then the carbon will have a filled outer shell, as it will have 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in total. I'm not going to draw in the lone electrons for all of the bromines because it's just time consuming, but you must draw the non-bonding electrons in, okay? Okay, the last one we're going to draw will be HCN. This is on your sheets. So you draw in the molecular formula, HCN, and then you draw out the atoms with their valence electrons. So we know that hydrogen has 1 valence electron, carbon has 4, and nitrogen has 5. We know that because of their valence group numbers, 1, 4, and 5 respectively. Okay, so we know that hydrogen can only form a single covalent bond, so we're going to draw a single covalent bond from the hydrogen to the carbon. like this. The hydrogen now has a filled outer shell. The carbon has one of its electrons in this single bond, and then it has 3 remaining. The nitrogen has not had any bonds yet, so it has 5 electrons. Can you see now the way that I've drawn it? If we have a triple bond here, both the carbon and the nitrogen will have filled outer shells. The nitrogen because it has these 6 electrons and these 2 to make 8, and the carbon because it has these 6 electrons and the 2 electrons in the single bond to the hydrogen. So you can draw it like this, or you can draw it like this. Just make sure you draw in your non-bonding electrons as well.